Everyone, we are back and we are going to talk today about really the fundamental courses that you're going to encounter in mechanical engineering. And those courses being kind of our 5 essential fundamental mechanics. So these courses are really the foundation of mechanical engineering. So when you take these courses, it's really critical that you do as best as you can to master these concepts, because everything else is going to build upon these foundational classes. So if we're not clear about some of the concepts that are taught in these courses now, it's going to be harder and harder as we can continue throughout our program, because these are going to be the assumed knowledge that we're going to use in all the rest of our classes. So make sure you do your absolute best in these courses. So our 5 fundamental mechanical courses are statics, dynamics, thermodynamics, solid mechanics, materials, mechanics of materials. You'll hear different kind of verbiage for this, and fluid mechanics. So statics, which we're going to cover actually a little bit in this class, is going to be looking at Newton's law, specifically sum of the forces equals ma equals 0. So we're looking at materials in static equilibrium, meaning some of the forces equal to 0, some of the moments is also equal to 0. So we're looking, how do we deal with objects like a beam, and when there's load is applied, what are the reaction forces? What are the reaction moments? How does this material, this actually perfectly rigid material, which means we're not assuming that there's any deformation of the actual material, how does it behave? Dynamics, we don't have a singular course that covers dynamics in our curriculum. It's covered actually in physics and also in basically vibrations. It's covered a little bit again in vibrations, but primarily dynamics is covered in our physics courses here at Cal Poly Humboldt. And dynamics, we're looking at some of the forces equals ma, and it's not equal to 0. So basically, we're looking at objects that are moving, that have some acceleration, moving at a non-constant velocity. So, and we're also looking at objects that are not only translating, but rotating as well. And we're going to get into a little bit of dynamics in our course as well. Thermodynamics is a very important course. It is looking at how do we determine what is the lowest energy in our system. So delta G equals delta H minus T delta S gives free energy. You can look at cycles. There's lots of different, basically the entropy of our universe is always greater than or equal to 0. We're expanding. So basically, second law of thermodynamics, you're looking at heat, lots of really fundamental aspects here. Solid mechanics and materials, we're going to get into that as well. So in statics, we assume that this beam is rigid, meaning the material won't deform, but we know that a beam will actually bow and the material will deform. Or, for example, when we stretch a system, we know that our material actually deforms a little bit. So we're going to be looking at how the actual material responds under mechanical stress. So we're going to be looking at materials, as I snooze this, and how do they respond under stresses. And then finally, fluid mechanics. How do fluids essentially respond? We're going to be looking at Reynolds numbers, all these kind of good things. So these are your 5 fundamental courses. So really make sure that you do as best as you can on those courses. So in the next video, we'll see how your time at Cal Poly Humboldt could look and how you want to kind of go about making your own curriculum. And so we'll see you in the next video. Thanks. Bye.